turn the thing on again, and now it's question and answer time.
The only thing you show here mainly single conductors. What if you have?
A bus?
Yeah.
They have bus. You see that over there? That's your bus technology. So it's a fatter line, okay? And what you do is you basically label your things and you hook them into the bus. And it just makes the schematic less cluttered. The other thing you'll see is like right there, you'll see a pin labeled RXD and TXD. That means I didn't draw the wire, but any two pins which have that label are electrically connected. There's different philosophies to schematics, okay? My philosophy on the schematic is you're trying to document your design, okay? So you're trying to present the information of what your circuit's going to do in the most comprehensible way possible. Now, if you have a maze of lines all over your schematic, it gets really hard to figure out what's going on. Now, there's the other alternative that I see a lot of people do, where they just put all the components on there, and then rather than drawing the wires, they label each pin with a wire name. I see that a lot. I don't kind of like that. I go in the middle, okay? I try to capture all the interesting wires that I think people want to see, and then for some of the ones where you're just running a wire from this pin to that pin because they've got to be connected, I will actually label those. My rule on wire labeling is I try not to do connect 3 or 4 parts with one label. I like it to just be connecting this pin to that pin with one wire and nothing in between. I view that as easy, somewhat easier to read. That's not everybody would agree with me on that. In fact, you get some people say, "Oh no, you should never do that. You should always draw every wire." And there'll be other people who say, "Nah, don't even bother. It's not worth the effort." So, I'm in the middle.
What about physical layout of the components? Should they be like left to right according to the logic of the circuit, or the way they're going to be physically on the board, or what?
I've seen it done both ways. Again, you're seeing a bit of a hybrid right here. The chip labels all the pins. That's because this is a template. What I do when I'm sort of done with a design is I delete all the pins that aren't being used because they're just clutter. Whenever possible, I try to do left to right, but a lot of times you can't arrange that because the signals go both ways. I try to, when I'm laying out the board, I try to get all the stuff that I usually write some text to explain what's going on, okay? And I try to make the flow of the text match the flow of the circuit the drawing left to the right. So I'm not going to re-scroll this, but all the power circuitry is usually on the left for me because I like to talk about how you're doing all your power conditioning first. And then you usually get to the microcontroller, and then all the stuff that the microcontroller does, I tend to put on the right. But that's just me. There's no right or wrong on this. It's whatever works for you. Yes?
The templates, did they give the pinouts and stuff, or did you put those in there?
Let's see. I drew up that template, and we are going to, at some point in time, show you. We're going to have to show you how to make your own components. So, in fact, the next class is drawing your own schematic component, and most of them are going to look like a rectangle. Okay, so you've got a new part you can't find anywhere. You're going to draw it up yourself, and the editor for creating this part is easy. Managing KiCad libraries takes a little getting used to. They're a little quirky, okay, and so we'll go through that. That's actually the next lecture is drawing your own part, okay. There are tutorials out there for KiCad, some videos. You're welcome to go dig them up. I think I'm a robotics guy. I think there's 4 or 5 that were done by the DPRG group. That's the Dallas Robotics group. That's kind of what I call them a sister club, although They're in Dallas, we're not. So, let's see.
They'd probably prefer Brother Group.
Brother Group, okay, whatever. They're really nice people, and we've had back and forth, we've had people come into the valley, and they've had people go back because there's a few more jobs in Texas these days. So,
You're,
I'm off, I'm sorry.
okay.
It's, the right thing for me to do is to have the light shining in my eyes. Okay. So, I think I answered that question. More questions?
Is this not on, are you using Ubuntu for this?
Yeah, I am.
That's
Yeah.
Ubuntu?
Yeah, this is Kubuntu, which is a version of Ubuntu, okay? But it's Linux. I mean, the Ubuntu and Kubuntu are distributions of Linux. Linux is the operating system, and then people put all these packages together and use them, and that's what I do. But this stuff I know works fine on Windows, and sounds like it works okay on Mac OS. So this is good. So the ultimate goal is, what I've decided was, when I was doing all this is just a prop. Sorry. Here, I'll use that as the prop. That it would probably be better to get everybody started using a template, okay, that has a microcontroller on it, that has all the JTAG wires and everything hooked up, rather than asking everybody to try and do that on their first project. So that's kind of why I'm doing it this way. I think we'd be better off having 10 projects where you're all just blinking an LED, but you've gone through all of these steps, than it would be to sort of throw you and say, blank sheet of paper, you do all the work. You're going to make way more mistakes that way. So that's kind of the strategy here. You can do a lot with a microcontroller these days. That is a very powerful microcontroller for this day and age. It's way more powerful than like the original computers that people were working on in the 40s and the 50s. Frankly, the 60s.
Maybe
More
the 70s.
powerful than what they used to get to the moon, probably.
Actually, probably it is.
A lot
yeah.
more powerful.
Yeah, actually a lot more powerful. Actually, a friend of mine in high school worked on the Apollo computer, which was a real tour de force. So
So in theory, we should be able to get to the moon.
you have to build a rocket. That's called rocket science.
Okay.
Okay. Other questions?
Last time you mentioned something about creating a busable Arduino board. What does
Okay.
busable mean?
Yeah, good. You asked about busable, and you found the board that I was looking for, but I couldn't see because I was being blinded by the light. This is the board. This is board. This is a motor board, and I had to rearrange the parts. But this is essentially the same thing as the template up there. It's got a bus connector here, and it's got the. See if I can move out of the way. No. Down here is the bus interface chip. It's called a CAN bus transceiver. And so using this template, every board that uses that template will be able to talk to the bus. Okay, the bus will be a 0.5 megabit using CAN transceiver technology, which is the same stuff that they use in most of your cars. It's extremely robust technology. It has to be, because otherwise your cars wouldn't work, or your cars would work more like certain operating systems developed up in Seattle area. So it's extremely robust, and it's off screen here, but that robot you see over there, it says danger, robot moves without warning. Well, that one is all bust together using this technology. And I bet you we lost it again. Nope, you got it in time. Okay, so you are the shift key pusher. So anyhow, that's what I do, and it doesn't have to use this chip. It can use I've used microchip parts, and I've used at-melt parts. It all talks to the bus. All you need is a UART. UART and the transceiver chip, and you can talk to the bus. So, and I think David Crawley is interested in as many people who are working on the Hercules project developing boards that can talk to the bus, because then everybody can just plug their boards into a robot, and it can be part of the whole rather than you having to build the whole robot. So, by the way, this is a religious thing for me. Okay, so I'm a huge fan of modular electronics, particularly for robots, and so I'm not giving you an unbiased opinion here. I'm giving you a very biased opinion. So I just want to be, truth in advertising here. Okay.
Is that bus well documented and?
Well documented. It is. I have a spec out there. There's a few pieces of the spec that are incomplete. Okay.
Are there easily accessible open source implementations of it?
I do have them all out there. I'm been a little sloppy on publishing the links. Okay, and so that's one of the things I'm going to be doing. The other thing I'm doing is I'm switching over from this really old crufty revision control system that I wrote 15 years ago because I didn't have anything nearly as cool as Git. And I'm switching over to Git. So I'm basically, as I pull each project into Git, it's going up to a public Git repository. So I'm 100% open source guy. I don't.
If you want help with maintaining the history, like translating the history from
Not interested.
to Git, I can help you.
Not interested.
Okay.
It's not important.
All right.
Okay. For me, it's just finding the cycles to just take each project, build a repository for it, throw it up on my repository site,
Okay.
and then go. And it's going to happen because the other thing we have to do fairly soon is we have to get you the footprint files, and that's another thing I have to shove up there. So anyhow, that's what I believe in. I really believe in modular electronics. Anything else?
You wanted us to connect a diode or a resistor. How'd you get the squiggly resistor? Doesn't seem to be in your library.
You copy the one that's already there.
You copy the one that's already in the template that I gave you. Okay.
So my installation of KiCad is missing a bunch of libraries, so it's something that you need to install.
I deliberately made for sure that all the components I used were in the library that were over there. Now there may be some glitching going on there, but library management is an issue with KiCad. I didn't want to deal with libraries this time. Okay, so I was trying like crazy to avoid
I
having
was
to do
trying to
it.
search for diode and
You should be able to find the diode over in devices, okay? They have a resistor in there, but it's a really ugly resistor. I'm old school. Resistors are supposed to be squiggles, okay? So I made my own resistor.
What does it look like? Yeah.
What? It looks like a square.
For a resistor?
A rectangle. It's
I went
very.
through every one of them they have in there, and there's no squiggle except
Yeah,
embedded within the
it's
resistor
the
pack.
stupid square one. It's Eagle uses that format too, and I hate it. I mean, one of the first things I was taught when I was in Double E was how to draw a resistor and how many bumps. There's supposed to be three zigs on each side. And the guy said you've got to draw them right, or we won't graduate you. So
What do you use for an inductor on there?
I
Square
don't-
again?
I know. I think you can draw an inductor. So.
I'm a one zig on each side guy.
Okay, that works for me too. But I was taught I wasn't going to be let out of school if I didn't put three zigs on each side.
I started with that.
Yeah. So okay, I'm going to sort of shut down here, and somebody will be the red button pusher. Sayonara.